Assalamualaikum and good day everyone. I hope everyone is having a good day, and if not, it's okay, it's just a bad day, not a bad life. Today our group 19 would like to share on the experiment of chemical oxygen demand or COD and biochemical oxygen demand or BOD, which both are the tests on wastewater samples. But before we start, allow me to introduce my group members. We are a group of chemical engineering students taking the course EKC291, Chemical Engineering Laboratory 1, for this semester in Universiti, Sains, Malaysia. Our group consists of 4 members, including Dhiwakar Chandran, me, Farah Zahidah, Li Ying, and Mohamad Zainul. Our group will share and explain some different parts. First off, we'll start with the theory of BOD and COD, which will be explained by my colleagues Li Ying and Dhiwakar. We need to understand the fundamentals of these two tests in order to perform the experiment. Then, we will proceed with the comparison of BOD and COD by Dhiwakar. Next, we'll go through the procedures of BOD and COD by me and Li Ying in order to perform the experiment. Finally, we'll come to the fun part, at least for our group, which is the results and discussions for both BOD and COD by Li Ying and Zainul. So let's start our discussion. What is exactly chemical oxygen demand or COD and biochemical oxygen demand tests? Both COD and BOD test methods aim to give an indication of the amount of pollution in a water sample. But there is a slight difference between these two tests. COD is the amount of oxygen required to chemically break down the pollutants. Meanwhile, BOD is the amount of oxygen to chemically break down the pollutants. Meanwhile, BOD is the amount of oxygen required to break down the pollutants biologically through microorganisms. Theoretically, COD analysis is a much faster and more accurate method. In this experiment, we will need to perform both tests by taking wastewater samples available in our campus. We took some water samples from some of the many lakes that are available in our lovely campus. One of the lakes that we chose is Redak Lake, which is located near Redak Center. And the other one is Lembaran Lake, which is located in front of Lembaran Cafe. Then we will proceed with the procedures, which will be explained later by my colleague.
Do you know what is biochemical oxygen demand? Biochemical oxygen demand (BOD) is the amount of oxygen utilized by microorganisms to decompose the organic compounds in a water sample under aerobic conditions over a specific period of time. Under aerobic conditions, the microorganisms will oxidize about 1/3 of the dissolved organic compounds to CO2 and H2O, whereas the remaining 2/3 will be converted to new microbial cells. The overall biological conversion starts with the oxidation of carbonaceous material, which is known as carbonaceous oxygen demand. Under continuing aerobic condition, the microorganisms will convert the nitrogen in organic compounds to nitrates, and this is known as nitrification oxygen demand. So, the overall BOD value will consist of these two demands. BOD test normally requires incubation of 5 days. The temperature of the sample during incubation is maintained at 20 degrees Celsius. The results of BOD tests are expressed as parts per milligram of water dissolved oxygen per liter water. They are obtained by finding the difference between the amount of dissolved oxygen in the water sample before incubation and after incubation. BOD test requires the addition of dilution water into the sample. This is because the dilution water contains nutrients such as nitrogen, phosphorus, and trace metals that can help for bacterial growth. In BOD tests, we can also add microbial seed to help for the digestion of organic compounds by the microorganisms. There are some limitations for BOD tests. First, some organic compounds may take more than 5 days to be biologically degraded by the microorganisms, so the BOD value measured in 5 days may not give the exact amount of pollutants existing in the wastewater. Furthermore, the BOD test is not suitable to test the industrial wastewater that contains toxic substances such as heavy metal ions and cyanides. This is because these substances may affect the biological activity of the microorganisms. Lastly, the time taken to measure the BOD is too long, and this may affect the biological activity of the microorganisms. In these 5 days, the pH value may drop and the nutrient supply may be insufficient for the microorganisms to survive for 5 days. Thus, the amount of microorganisms existing is limited. Why do we need to conduct BOD tests? Well, BOD test is very important. It can help us to determine the degree of pollution in water bodies and also the efficiency of water treatment plants. In fact, the BOD value of the industrial effluent discharge in Malaysia has been limited to some values. According to Malaysia Environmental Quality Act, for the industrial effluent of standard air, its BOD5 value at 20 degrees Celsius should not exceed 20 mg per liter, whereas for industrial effluent of standard B, its BOD5 value at 20 degrees Celsius should not exceed 50 mg per liter. Standard A refers to the inland water within specific catchment areas. Standard B refers to any other inland waters or Malaysian waters. For the industrial effluent other than of standards A and B, its BOD5 value at 20 degrees Celsius is limited to 400 mg per liter.
What we know about this COD? COD refers to the chemical oxygen demand, which measures the amount of dissolved oxygen in sample water, which converts organic compound to carbon dioxide and water. Expressed in mass of oxygen consumed over volume of solution in milligrams per liter. This test is based on the fact that a strong oxidizing agent under acidic conditions can fully oxidize almost any organic compound to carbon dioxide. The COD is the amount of oxygen consumed to chemically oxidize organic water contaminants to inorganic end products. The COD is often measured using strong oxidant, example like potassium dichromate, potassium iodate, potassium permanganate under acidic conditions. The known excess amount of the oxidant is added to the sample. Once oxidation is complete, the concentration of organics in the sample is calculated by measuring the amount of oxidant remaining in the solution. This is usually done by the titration using an indicator solution. COD is expressed in milligram per liter, which indicates the mass of oxygen consumed per liter of solution. The COD test only requires 2 to 3 hours, while the biochemical or biological oxygen demand test requires 5 days. It measures all organic contaminants, including those that are not biodegradable. COD test results can then be measured to estimate the BOD of a given sample. Unlike the BOD test, toxic compounds such as heavy metals and cyanides in the samples to be analyzed do not have an effect on the oxidants used in the COD test. Therefore, the COD test can be used to measure the strength of waste there are two toxics for the BOD test. Theory test is very important to determine the degree of pollution in water bodies and to determine the efficiency of water treatment plant. As according to the Malaysian Environmental Quality Act, there are a set of limits of theory tests which we should refer. The standard A should be 50 mg per liter and standard B should be 100 mg per liter. Okay, there are several significant comparisons of BOD and COD tests. At first, the BOD is the amount of oxygen required by the bacteria while decomposing organic matter under aerobic conditions, while COD is the oxygen required for the oxidation of total organic matter in water. BOD is a biological oxidation process, while COD is a chemical oxidation process. BOD determined by incubating a sealed water under specific temperature sample for 5 days and measuring the loss of oxygen from the beginning of the test. But the COD determined by incubating a closed water sample with a strong oxidant like potassium dichromate in combination with boiling sulfuric acid under specific temperature for a specified period of time. 5 days are taken for the determination of BOD, while COD measurement can be taken from a few days. The permissible limit for BOD is 30 mg per liter, while the permissible limit for COD is 250 to 500 ppm. The BOD value is lower than COD value, but the COD value always greater than BOD value. BOD capable of oxidizing natural organic detritus and the organic waste in the water, while COD capable of degrading industrial sewage but does not measure the oxygen consumption of acetate. The common test for BOD is method 5210B, and the common test method is method 410.4. BOD is affected by toxic substance and temperature, while COD is not affected by the toxic substances and temperature. BOD has accuracy more or less 10%, while COD has accuracy more or less 2%.
Now, let me explain briefly about COD test first. COD test is conducted by using dichromate reflux method. In this method, a known amount of potassium dichromate and a strong acid reagent are added into the water sample. The mixture is then refluxed. During the reflux process, the organic compounds in the sample are oxidized. At the same time, dichromate is reduced to tribarium chromium. The sample is then titrated with ferrous ammonium sulfate to measure the remaining dichromate in the sample. We then find the amount of potassium dichromate consumed and its equivalent amount of oxidizable organic matter in the sample. Now, let us see how to conduct COD tests. To conduct COD tests, we need to prepare some reagents, which are 0.1417 molar of standard potassium dichromate solution, sulfuric acid reagent, fluorine indicator solution, standard ferrous ammonium sulfate FAS titrant, and mercury sulfate. First, we need to collect some water samples. In this experiment, the water samples that we collect were from the Baran lab and Redact lab in our campus. Then we transfer 50 ml of the water sample into a refluxing flask. Now, add 1 gram of mercury sulfate, several glass beads, and 5 ml of sulfuric acid reagent into the refluxing flask. The sulfuric acid reagent should be added very slowly. Make sure that the mercury sulfate dissolves completely and cool the mixture while mixing to avoid loss of relative materials. Next, add 25 ml of 0.0417 molar of potassium dichromate solution into the mixture. After that, attach the refluxing flask to the condenser. Turn on the cooling water to let it flow through the condenser. Then, add 70 ml of sulfuric acid reagent into the refluxing flask through the open end of condenser. Remember to continue stirring and mixing while adding the sulfuric acid reagent. Now, cover the open end of the condenser with a small beaker so the foreign material will not enter the mixture. Wait the mixture to be refluxed for 2 hours. Within these 2 hours, the condenser is continually cooled and washed with the distilled water. 2 hours have reached. Now we can disconnect the refluxing flask from the condenser. Add the distilled water into the refluxing flask to dilute the mixture to about twice its volume. Then, let the mixture to cool down to room temperature. Next, titrate the sample with ferrous ammonium sulfate using 2 to 3 drops of ferrine indicator. The endpoint of the titration is taken when the blue-green solution changes to reddish brown. Repeat the titration for the same sample with the same amount to get a more accurate result. After that, we repeat the whole experiment by using blank sample to replace the water sample. The blank sample is prepared by using distilled water that has the same volume with the water sample.
Unlike the COD test, the BOD analysis test usually will take 5 days in order to be able to see the results. So first, the method consists of filling with the sample to overflowing an airtight bottle to the specified temperature for 5 days. Next, dissolved oxygen is measured initially and after incubation. Then, BOD is computed from the difference between initial and final BOD. Due to the initial BOD is determined immediately after the dilution is made, all oxygen uptake, including that occurring during the first 15 minutes, is included in the BOD experiment.
Now, we are going to show you how to calculate BOD value based on our results for BOD test. To calculate BOD value, first we need to collect burette readings during the titration of samples on the day when we collect the samples. We also need to collect burette readings during the titration of the samples that have been incubated for 7 days. However, our group was unable to collect data on 7 days. After collecting data, we need to calculate the volume of natrium thiosulfate added for each titration. As we know, the endpoint of titration for BOD test is taken when all the blue color in the solution disappears, meaning that the solution becomes colorless. So, to calculate the volume of natrium thiosulfate added for each titration, we just need to subtract the burette readings taken at the endpoint of titration from the initial burette readings. After calculating the volume of natrium thiosulfate added for each titration, we can then use these values to calculate the average volume of natrium thiosulfate added for each sample. Now let us refer to the formula to calculate the BOD value. This is the formula for BOD. A is the amount of dissolved oxygen of sample before incubation. B is the amount of dissolved oxygen of sample after incubation. C is the amount of dissolved oxygen of blank before incubation. D is the amount of dissolved oxygen of blank after incubation. N is the dilution factor. In this experiment, our dilution factor was taken as 100. This is because all of our samples were diluted to ratio of 1 to 100. To calculate the BOD value of lead water 1 based on our collected data, this is the value for A, this is the value for B, this is the value for C, this is the value of D. We can just substitute these values into the formula of BOD and get the answer. Then we use the same way to calculate the BOD value for lead water 2, just the values for A and B are different. However, since our group was unable to finish the BOD test, so we cannot use this way to calculate the BOD value. Well, there is another way to calculate the BOD value. As we know, the BOD value measures the amount of biodegradable organic matter, whereas the COD value measures the amount of biodegradable and non-biodegradable organic matter. So we know that the BOD value of a sample is always less than its COD value. We also found that the ratio of BOD to COD is constant after a period of time. Thus, we can know that the ratio of BOD to COD is always less than 1, and we assume it is 0.7 for our case. Hence, we can make a prediction for BOD value for each sample based on their COD values by using the ratio of 0.7. So we calculate that the BOD value for lead water 1, which is the lembaran lead, is 569.26 mg per liter, whereas the BOD value for lead water 2, which is redex lead, is 380.4976 mg per liter. From these results, we can see that lembaran lead has higher BOD value than redex lead. This means that lembaran lead contains more biodegradable organic matter as compared to redex lead. That's why more oxygen is used by microorganisms to decompose the organic compounds in lembaran lead. So, it has larger difference between the amount of dissolved oxygen before incubation and the amount of dissolved oxygen after the incubation. Hence, we can conclude that lembaran lead is more polluted than redex lead. However, our results may be inaccurate because the water samples were taken from different points of source, so the legs may have different ratios of BOD to COD.
Hi, my name is Mohamad Zainul. Today I'm going to present the result of the discussion, error analysis and conclusion. First of all, I want to present the result of the chemical oxygen demand, which is COD. So, let lead water 1 as lead water taken from lembaran lead and lead water 2 as lead water taken from redex lead. As we can see on table 1, it is experimental data of chemical oxygen demand test. There are 3 samples, which is lead water 1, lead water 2 and blank solution. For each sample, we take the burette reading, and each sample we took 2 readings. Next is the sample calculation for lead water 1. First, we do calculation of average volume of ferrous ammonium sulfate, which is FAS, added for trial 1. To get the volume of FAS added, the formula is burette reading for reddish brown minus burette reading for initial. So 7.9 ml minus 0 ml, we get 7.9 ml. Same for trial 2. We use the formula to get the volume of FAS added, which is equal to 8.7 ml. Okay. After we obtain the volume of FAS added for 2 trials, we need to calculate the average reading of it. So, volume of FAS added in trial 1 plus volume of FAS added in trial 2 divided by 2. So, 7.9 ml plus 8.7 ml divided by 2, we get 8.3 ml. So, next calculation, we calculate for the molarity of FAS and COD value. The formula of molarity of FAS solution is the volume of 0.0417 molar of potassium dichromate solution titrates times 0.25 divided by volume FAS used in titration. Hence, 25 ml times 0.25 divided by 8.3 ml equal to 0.756 molar. Next is the formula for COD as milligram oxygen per liter equal to bracket A minus B close bracket times C times 8000 divided by milliliter sample, where A is FAS used for blank, B FAS used for sample, and C molarity of FAS. By using the formula, we obtain 813.24 mg per liter. So, in this table 2, which is data tabulation of COD test, we conclude all the data for each sample by using the formula before. As we can see, the COD value for lake water 1 is 813.24 mg per liter and COD value for lake water 2 is 543.568 mg per liter. The next part is the discussion for chemical oxygen demand. In COD test, potassium dichromate was added to the wastewater sample, followed by the addition of sulfuric acid reagent. The potassium dichromate will act as the strong oxidizing agent under acidic condition. Potassium dichromate would oxidize the organic matter in the wastewater sample by reducing itself from dichromate to trivalent chromium. After all the organic matters in the wastewater sample will completely oxidize, the amount of remaining dichromate in the sample was determined by nitrate with ferrous ammonium sulfate (FAS) that reduced dichromate to trivalent chromium. As we can see, the overall equation of the redox reaction was shown below. During the titration, a color indicator was used, which was ferroin indicator solution. Once all the excess dichromate remained in the sample was reduced to trivalent chromium, ferroin indicator would change from blue to green to reddish brown. Hence, if the amount of FAS added was less excess dichromate remained in the wastewater sample. This indicates that more dichromate had been used to oxidize organic matter in the sample. So, we could conclude that the sample had more pollutant and have high COD value. Next, based on the result of COD test, the COD value calculated for lake water from Lembaran Lake was 813.24 mg per liter, whereas the COD value calculated for lake water taken from Lidek Lake was 543.568 mg per liter. Since lake water taken from Lembaran Lake was found to have higher COD value than lake water taken from Lidek Lake, this indicates that it requires more oxygen to chemically oxidize its organic matters. Thus, we could conclude that Lembaran Lake contains more pollutant compared to Lidek Lake. So, the next part is error analysis from our experiment. There were some errors that might occur during the experiment, causing the result of the experiment to be inaccurate. First and foremost, parallax error might happen due to the position of our eye not perpendicular to the scale of the instrument, such as measuring cylinder and burette. Thus, the volume measure might have low accuracy. Furthermore, human error might also occur when we carry out the titration. This was because we hardly determined the point of titration when the yellow solution becomes pale color in BOD test, and the point of titration when the green solution becomes blue-green, as it was difficult for us to differentiate these similar color. In addition, sometimes we might miss the first shape color change, so the endpoint of titration taken might be inaccurate. Hence, to overcome this problem, we should repeat the titration and take the average reading. We should also carry out the titration as slow as possible so we could observe the change when every drop of titrant was added. Moreover, the apparatus might be contaminated, causing the result of the experiment to have some deviation. Thus, we should clean all the apparatus properly before we use them. The last part is the conclusion. We managed to correctly perform COD analysis and a part of BOD analysis for a set of wastewater samples, which were the lake water of Lembaran and the lake water of Rhydat in our campus. By obtaining the COD and BOD value, we could determine the amount of pollutant in the wastewater sample and the quality of the wastewater sample. Based on the result of our experiment, we found that the lake water of Lembaran had higher COD value, which was 813.24 mg per liter, compared to the lake water of Rhydat, which had a COD value of 543.568 mg per liter. Hence, we could conclude that Lembaran Lake was more polluted than Rhydat Lake. Theoretically, we knew that the value of COD was always higher than the value of BOD, as COD determines the amount of organic matter and inorganic matter in the water sample, whereas BOD only determines the amount of biodegradable organic matter in the wastewater sample. Thus, we estimate the BOD value for Lembaran Lake and Rhydat Lake based on their COD value, as we also knew that the ratio of BOD to COD for a particular sample will remain unchanged over a period of time. Hence, we found that Lembaran Lake had a BOD value of 569.268 mg per liter, whereas Rhydat Lake had a BOD value of 380.4976 mg per liter. However, this BOD value were not inaccurate. To get more accurate result of BOD value, we should conduct BOD tests instead of making prediction. So, that's all for me. Thank you for your attention.